Hi, my name is Sumi Helal. I'm a professor at the University of Florida and director of the Mobile and Pervasive Computing Lab. I will talk today about a demo that I have shown in Qualcomm recently, the Atlas IoT. And before I go over the demo, myself and my student Ahmed, Khaled, I would like to give a brief introduction about Atlas. So Atlas is a project that we have started here at the University of Florida to look at the issue of fragmentation. The market is so fragmented with all kinds of devices. How can you ever build a system of large amount of devices without using system integration, without having to go through the step of integrating things together? How can devices self-integrate into a system? So we started that project a number of years ago, and we have created middleware and also a sensor platform. So this is our Atlas board, and it is a stackable modular architecture. This node here is a Zigbee node, antenna, and then upward communication, which is Zigbee, brain, which is an Atmel Atmega, and then downward we have a variety of boards to connect to devices. So we created Atlas so that when we connect devices into the Atlas platform that has middleware in it, when we connect and power on, the device gets to be represented in the network. So today we have evolved that architecture so that a device is represented in a gateway and also the cloud. This kind of externalization allows us to convert any large collection of devices into simply a software project. So programming the system of devices become easily facilitated and allow us to create application that have meaningful life cycle where you can update the application, edit it, and change the logic without having to go down to the devices or physically access the devices. So that is Atlas, and we have deployed Atlas in the Gator Tech Smart House. It's well published. There are 2 US patents on Atlas technology. Now, moving from Atlas into Atlas IoT, the subject of the demo today. Atlas IoT look at industrial IoT and personal IoT and try to look at the issue of how can we actually create things that are manageable, that can be securely managed remotely, and that can sort of communicate with other things to allow for interesting applications. So the particular demo that we'll show today involve a heterogeneous set of things, and we will focus on a particular architecture. We call it Atlas Thing architecture. And as you see here in the picture, the Thing architecture is something that you overlay over an operating system. So it means that there are additional layers really needed to enable things in the Internet of Things, in addition to the standard operating system services. And some of this, as you see here in the lower part, we're looking at what's called device description layer, in which devices get to be described by something like a device driver. We call it a device description language manifest. That descriptor basically enables devices to generate its own API and exchange knowledge and communicate with other things to really enable a new ecosystem of programming. But most importantly, for these things to have any meaning, the software, including the DDL and all these other layers, need to be dynamic, need to be sort of managed. So we use device management standards such as OMA-DM and IPSO to sort of provision these things, to provision the software layers on the things, and to also update them securely. So security is of paramount importance to us, and the demo will show you how an OMA-DM client embedded into our Thing architecture implementation in a variety of boards, how they actually respond to an OMA-DM server that's trying to change the DDLs and the very definition of things. Changing become very important, especially in wake of recent attacks. For example, to do application fuzzing and to change things and to just batch up security patches into these devices. So I will stop here, and I will let my student Ahmed, Khaled, go over the demo with you.
Hi, my name is Ahmed Khaled. I'm a PhD student here in University of Florida, working with Professor Sumi Helal on platforms for Internet of Things. Our demo here is about deploying Atlas architecture on 3 different types of things. The first one is a Beagle Pwn plug, and it's connected to a relay module that controls the kettle for boiling water. And the second one is a Dragon Board 410C, and it's connected to a software service, it's alarm clock service. And the third one is a Raspberry Pi Model P+. Actually, starting these three things is from our controller SSH channel for everyone, and then these three things started communicating with each other and with the OMA server represented in the Linux shuttle here. We can proceed with the video and see how the application is turning on the kettle when specific time triggers. From a laptop on the same network, we SSH the three different things to start Atlas on them, and in the background an OMA server represented in Linux shuttle is running. Each thing then starts tweeting its identity and service to other things, at the same time register itself as OMA client on the server. In this demo, the Dragon board with software alarm clock exchange identity and service tweets with a Beagle Pwn plug with coffee preparing service. The Dragon board then asks the Beagle Pwn to prepare coffee when time triggers. The OMA server is imported from an open source implementation of OMA protocol for device management developed by Wakama Working Group of Eclipse. Atlas architecture extends the client side of Wakama to include set of OMA-based objects named Atlas objects. This object describes every aspect of the thing. The server runs on Linux shuttle and offers three main functions. The first one is listing all the registered things. The second one is reading any of the objects, either OMA or Atlas object of a specific thing. And the third one is modifying these objects.